So 7.0 is just on geometry basics. And for the most part, you guys have probably seen the majority of this sometime in your math past. So we're just going to go through some basics that we need to make sure we remember so that we will be able to move on with the rest of this unit. So the first thing we want to talk about is just the triangle sum theorem. And what that means is that if you add the three angles of any triangle, they will always add up to be 180 degrees. So we'll just write that as the sum of all three angles of a triangle is 180. And the same thing's going to happen with a quadrilateral. So a quadrilateral just is anything with four sides. And so as we look at that, the same thing, if we think about a quadrilateral, it's made up of two triangles. And so if we have two triangles that add up to 180, then a quadrilateral would add up to be 360. So we'll say the sum of the four angles of a quadrilateral is 360. We also can look at either one of these shapes and have to name them by the vertice letters. And so as we look at this triangle, we can either call this triangle ABC. And so we're going to start at A, go to B, and then to C. So we name it in the order that we are saying it. So we go A, B, and then C. Or we could name it triangle. If we started with C, we could do CAB. We could do triangle BAC. We could do triangle ACB. And again, these are all the same triangle, just the order that we're stating it in. So we could do CBA, or we could do triangle BCA. So these are, whoops, let's see that again. So these are all the same triangle, but just a different order of the vertices. Now, sometimes the order matters if we're talking about the congruency of two triangles or two shapes. But if I'm just naming it, it doesn't really matter. And the same thing happens with a quadrilateral. We can either name it as a quadrilateral ABCD. We could name it as any of those orders. So we could do BCDA. We could do CDAB, and so forth. So we can go through all of those, and they all are talking about the same four-sided shape. So again, I could have gone and then backwards of all of those. So I can either do ADCB and so forth. So just the order doesn't matter. There's lots of different ways for us to name them. Whoops, that's not a rectangle. And again, just forwards or backwards. So if I went A, D, C, B, I could do D, C, B, A, C, B, A, D, and I could do, let's see, C, B, or I could do B, A, D, C. And same thing, I can start with, I can put it in whatever order, but it's exactly still the same shape. If I'm looking at just an angle, a little bit different. So as I'm looking at this angle, I do need to worry about the order a little bit. So if I'm starting at X, then I can either call this X, Y, Z, or I could call this X, Y, P, because those are all the points that are on this angle. Okay, or I can name it the other way. Okay, so the other way would mean that I could do z, y, x, or I could do p, y, x. But notice that I can't start with z and go to x because it's not a closed shape. So we're just talking about the angle. So I can either go x, y, z, or x, y, p, or I can go the other way and go backwards. So I can go z, p, or z, y, x, or I can go p, y, x. But again, because it's an angle, I can only do these two different ways. If I look at the triangles that are created in this figure, then it's going to be the same thing. So I can either start with B, so I could do triangle BED, and that's really the same thing as saying triangle EDB, or I could call it triangle DEB, or I can call it triangle BDE. All of these are the same. It's the same triangle that we're talking about. Now, same thing with the bottom triangle. I can either call it triangle ABC. I can call it triangle BCA. I could call it triangle CAB. Oh, whoops. Or I can call it triangle BAC. And these are all the same triangle. I'm just saying it in a different order. So a couple other things that we want to look at is perpendicular lines. The definition of perpendicular lines are lines that cross. Let's see that a different way. So lines that cross and form 90-degree angles. So if you notice the picture, if these two lines cross, it forms 4 right angles. So we've got one here, one here, one here, and one here. So each of these are 90 degrees. Congruent, if I talk about congruent shapes, it means that you have congruent angles and you have congruent sides. So if two shapes have congruent angles and congruent sides, then the figures are congruent or the same. Whereas similar means that you have congruent angles and your sides are proportional. So congruent angles, sides are proportional. So I want to talk about the difference between the two when you're looking at the markings. So again, as we look at the markings, notice how we have angles marked. So notice that when I talk about congruent angles, I have this side is congruent to this, or I should say this angle. So angle B in the first picture is congruent to angle E in the second. Angle, maybe I'll do it in a different color. Angle A has 2 markings or 2 arcs, is congruent to angle D, 2 marks. And then angle C has 3 marks and is congruent to angle F, which has 3 marks. And then we talk about sides the same. We've got 1 mark, which means side AB is congruent to the 1 mark, so side ED. And then we have 2 marks, so side AC is congruent to side DF. And then we have our third side, which has 3 marks or 3 dashes, and that's congruent. So CB is congruent to FE because it has 3 markings. So now when we look at similar, notice that it's stated a little bit different. We've got one side or one angle. Angle A is congruent to angle C. we have angle B is congruent to angle E. And then we have angle C congruent to angle F. So that's where we talk about our congruent angles. So our angles are congruent, and then we look at our sides, and our sides are proportional. So when we're looking at proportional sides, we're talking about the sides that, in this case, we're going to say the smallest, or the between the two markings, or the pink and the blue as I've marked them. So this side of 6 and 12, if we look at that, 6 over 12 should equal the same ratio as the other two sides. So as we look at between the green and the blue is a 7, and between the green and the blue is a 14. And so we're going to go 7 to 14. And then the same thing here. We've got 10 is to 20. And you'll notice that all of those reduce down to be 1 over 2. And so that means that our sides are proportional. So that's just part of talking about proportional sides. When we're naming congruency, we use, so we can say the triangle. And as we name the first one matters. So as I name, or the first one doesn't matter, I should say. So we're going to name it as triangle ABC. When I do congruent, I use an equal sign with the little squiggly over it, which is congruent, is triangle 2. And as we look at it, we go A, B, C. And notice that goes 2 markings to the 1 marking to the 3 markings. And so I'm going to do the same thing on the other triangle. So it's going to go 2 markings, 1 marking, 3 markings. Or in our case, we went pink, blue, green. So we're going to do the pink, blue, green, or 2, 1, 3. So it's going to be to triangle D, E, F. So that's if we're doing congruency. And again, we have to have the congruent angles in the same position. We're going to do the same thing with similar, except for the way we do similar is we don't have the equal sign. We're just going to do the squiggly. So as I look at the first triangle in this case, we're going to call it ABC again. But instead of congruent, we're going to say similar. So we're just going to do the little squiggly. So triangle. And then notice that if I do ABC, I'm going from 1 mark, 2 marks, 3 marks. So I'm going to go 1 arc, 2 arcs, 3 arcs. And so ABC is going to be similar to triangle DEF. And the way we mark our figures matter. So make sure that as we're naming them, that the order matters on the second one. It's based off of congruency from the first triangle. As we look at vertical angles are congruent, and they're the angles that are across from each other. So we're going to say they're congruent. So vertical angles are congruent, which means they're the same. And they're the angles that are across. Are across from each other when 2 lines intersect. So when we look at that, we've got angles 1 and 3. So we've got our 2 lines that are intersecting. 1 and 3 are across from each other, and then 2 and 4 are across from each other, and they're equal to each other. And then we've got complementary angles. So complementary angles are 2 angles whose sum is 90. So you notice that 59 plus 31, if I add them together, it equals 90 degrees. So that means that those 2 angles are complementary. Supplementary angles are 2 angles who add up to 180 degrees. These are also called a linear pair. So they form a line. Just squeeze that in. So again, you'll notice that 120 plus 60 is 180. And 180 degrees is what the sum of a straight line is always. And then our last little part talks about the angle measure of a straight line. And like I said, a line is always 180 degrees. So as we look at this, we know that angle A, the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 degrees. So as we look at this for this example, it basically ties everything in. So as we're looking, we know that if we have this angle right here of 135, we know the angle diagonal from it, those form vertical angles. So here's our two lines that intersect. So if this is 135, then angle C is 135. We also know that this is a straight line. So if we have 135 here, we know that if to find angle A would equal 180 minus 135. And you guys can do that in your calculator or however you want to do that. So that's going to give us 45 for angle A. So if angle A is 45, then we know angle B is 45 because these two angles are vertical angles. And if we know that's 45 and we know that this is 90, we know that all three angles of a triangle have to add up to be 180. So 90 minus 45, or 90 plus 45, subtracted from 180 is going to give us 45. Or you can just go 90 minus 45, which gives us angle D, which is 45. And if we know that this angle is 45, then we also know that angle G is 45. And again, we know that because these are those are vertical angles. As we look, kind of the same idea. This is going to be two lines that cross. And so we know that if angle D is 45, this forms a straight line. So it's a linear pair. So if I do 180 minus 45, then I'm going to get angle F is 135. Oops, not angle F. But if angle F is 140 or 135, then angle E is 135 because those are vertical angles. So F and E are vertical angles. And so if angle E is 135, let's write that in. So if this is 135, then we know that angle H, because this is now a triangle, we know that angle H has to be, so this angle right here has to be 180 minus 135 minus 35, because all three angles of a triangle have to add up to be 180 degrees. So as we look at that, we know that angle H has to be 10 degrees because that's 180 minus 170. And then we also know that if these are perpendicular lines because you have a right angle here, then we also know that this is a right angle on this side. And so I know that angle I is going to be 90 minus 35, because we know that if this is perpendicular, that also means that K and J have to be 90 degrees. And so I is a portion of that 90. And so 90 minus 35 is going to give us 45. And that would give us all of our values right there. That 45. It's actually 55. And then that's everything for 7.0.